Hello there. In this video I'm going to show you how you can use an Enneper curve in Fluid Designer for 3D printing to create this pendant here. The others are also actually made out of the Enneper curve as well, but with just different P and Q values. But the principle of making them is pretty much the same thing. So if we go to Fluid Designer for 3D printing, we are going to use a couple of components here. I am going to use a connector. This is just going to be used to put the chain through the object, so we're going to have to append a connector to our workspace. And if I just show you the different types of gem settings that you can see, I'll show you we're going to actually create a pendant with an oval gem. I'll show you that also with Enneper curves you can use Trillium gemstones as well quite easily. I'm going to use a bezel setting. So if I select gem settings bezel, now all of these objects are basically set up to be rings at the moment, and we just I'm going to look for the oval one, and if I just drag and drop that object onto the workspace, there is essentially a ring, and I can change the dimensions of my ring here by changing the cross section. That obviously doesn't work with that size of gem. Now the default gem is they're all actually 10 millimeters, so the size of this gem at the moment is 10 millimeters, and that's what we need to work to. And these are all parametric smart objects, so we can change values over here in curve data information and change the size of the cross section, in this case of a ring. Now I'm going to use these to create my pendant. That's why I'm keeping them on the in the workspace at the moment. But I don't need this ring, so I'm going to I'll just switch on screencast keys, so any key presses I make should be displayed down here. So I'm just going to hit the X key on the keyboard and just delete the ring. And if I just go to view and top view now, I'm just going to move that up a little bit and move the oval gem up a little bit as well, just while I work with my Enneper curve. Okay, so if I just go to view and top view again, so I'm going to create my Enneper curve here. Now I need to open my toolbox, because in creating the Enneper curve I need to set some variables over here. So if I go to add curve and Enneper, you'll see that that's the default object. Now the grid size is about 20 millimeters square approximately, so that gives you an idea of the size of the finished object. So that's basically what I'm going to try and work to. So at the moment this is just the maximum dimension of this is 9 millimeters. But we're going to change the shape of this, and we do that in the window over here. Now the first thing I want to change is the resolution. The resolution is the number of control points around this curve. Now if I change the bezel here down to 0, you'll see the raw curve there, and if I press the tab key on the keyboard, what we've got there is 180 control points around that curve. That's the default one. Now I'm just going to press X and delete that default one and add the curve again, because whenever I go into edit mode I can't go back over to change these parameters here. Now I don't want 180 points here, so I'm actually going to change that down to 30. I'm going to leave the height at 0.5, but I want to scale this up a little bit. So if I hold down the left mouse button and just drag it, I can just scale it up to about the size of the grid. In other words, about 20 millimeters by 20 millimeters. Now I'm going to put the bevel back in there to give you the thickness. Now 0.5 is actually the radius thickness of this circular cross section. What that means is that this thickness here is 1 millimeter. So that just gives you a default setting that you can work to, but we can change that over here, and we'll do that in a minute. Now the next thing I want to do is I need to tick this plus options always when working with these curves, set rounds down to 1. Otherwise you can end up with problems when you're trying to 3D print this object, because rounds of 2 and 3, they tend to overlap each other, and that's no good for 3D printing. Now the next thing that we need to do is to change the P and Q values, and you can see what happens as I do this. We get a different shape, a different pattern for our curve. And if I change this up to, I'll do 9, and I'll do 9 by 6 for example, you can see that I get that pattern. And if I just increase the scale a little bit, you can see it fills out my grid there, so I can change the scale as well as changing the pattern sometimes. Now if I just click on Group Library there to refresh this list here and go to Gem Shapes, if I just scroll down to Oval Gem, that's this one here, if you look at this shape, if I just move this window back a little bit, here is an oval shape. So we could put an oval gem into this if we made this, if we 3D printed this and made it as a pendant. Now what we'll also find is if I take the numbers down again, you'll notice that the shape here changes, and that's a kind of pentagon shape with it 9 by 5, so that's not very suitable for the gemstones that you might have unless you get one specially made. Notice if I go down to 9 by 4, we get our oval shape again, and again there is a kind of oval pattern there, but this bit's in the way. So what you need to do is you do need to sort of like, oh, and that one there, look, if we look at that pattern there, that's a little bit like a cushion gem. So depending upon the pattern, you may have to vary it to suit the gemstones that you're going to use. So I'm going to oh, and there's one other pattern that does seem to appear quite often here. There's this shape here, which is a kind of triangular shape, and you can actually get trillion gems to fit in there when you make further adjustments to it. Now I'm going to take this right back down to 2 again, and you'll see that I keep getting oval shapes here. You can see perhaps there's a little bit of a trillion shape there, but not quite right. That one would be a trillion gem. Look, if you look at that shape there. When I take it back to 3 by 2, what I get at the top here is an oval shape. So I'm going to work with that one. So those are the settings that I'm going to have. Actually, I'm going to scale it down just a little bit, take it down to about 3, or just over 3 there. So that gives me approximate dimensions of 20 millimeters by 20 millimeters. So remember that to put this at 1, and I can now set the bevel back to 0 just to see what the raw curve looks like, and I can shut my toolbox down now. And what I'm going to do is I'm going to add my bevel over here. Now these settings are really for this bezel ring here. The early ones are settings for the bezel ring itself, which we'll adjust in a minute. If I just scroll down here and look for settings for the pendant, so I want my cross sections here, so I could do 1 by 1, so that's 1 millimeter by 1 millimeter. So this is a parametric smart object now, so we can change this to different values and see what they look like. So there's 1 by 3, so that's 1 millimeter across and 2 and 3 millimeters deep. Now that will give you quite a rigid structure for this, so you could set it at 1 by 3. In fact, yeah, I think I'll leave it as 1 by 3 in this instance, but obviously you can play around with that and get different values. Now if I go to View and Top View, you can see my oval shape there. Now what I want to do is to use this bezel ring and fit it into here. Now the first thing I want to do is to rotate it about the x-axis 90 degrees. So if I go R on the keyboard, X and 90, that will pull it to that orientation, and if I just go cursor and snap selection to cursor, it will actually put it right in the middle of the screen for me. Center it in the same way that this object is centered as well. And now I need to do the same thing with the gem. So it's R on the keyboard, X and 90 to rotate it 90 degrees. And with it selected, snap the selection means this object, snap it to the cursor to the center of the screen there. So that positions that nicely. Now what we want to do is to scale up this bezel ring, and I'll position the height of it later. I want to scale it up so that it fits here around the actual pendant itself. So I can do that by S on the keyboard for scale, and if I just pull that out until it gets to the right sort of size. Okay, so yeah, I can I'm actually going to have to, I think, go back and adjust my thickness of my yeah, let me just cancel that for a moment. I've set this at 1:3. I think what I need to do is I need to actually go back and change this. You'll see why in a second. Let me change it to 3:1, or well, I'll actually change it to 2:1. And you'll see why in a minute. So if I change that to 2:1, so that's 2 there and 1 there. And if I just go back and view it from the top view now, and click on that bezel there. Now if I now scale this, and as I'm scaling it, I'm just moving this window out of the way, watch the value appear up here. So if I press S on the keyboard and pull the mouse out to scale it, you can see I've scaled it up to 2, and when I click enter, you can see that I can see under part of the gem, of the pendant, sorry, there, and I want to use that bit as the backing for the actual gemstone to fit itself. So I need to move this down, and I want the gemstone to fit on that back face there. Now whenever you're scaling Fluid Designer, you must always do Control A and apply the scale, and watch the thickness of that object reset itself. If you don't do that, the cross section of this will not be the value as indicated over here. It will be something completely different, and you won't quite know where you're standing. So always do Control A and apply the scale. Now what I can do is I can move that down until it intersects with the back of the pendant there. So you want some overlap. And clearly now we're in a position whereby the gem, and I need to scale this up by the same amount, so S on the keyboard, and I'll just type 1.6. No, sorry, type 2 I did. Scale it, not 12, scale it up 2, and Control A and apply the scale. Not so important with this object because we're not going to print it. So what you can see now is that that gem will fit in there, and the bezel will be pushed over the gem to keep it in place. Now if I just hide the bezel ring for the moment, you can see that when you do this, the actual gem, and I'll just switch off the snap here, the actual gem will fit on that back face there to hold it in place, and then the bezel ring will need to be folded over. Now in order to determine the actual dimensions of this bezel ring, you will need to know your exact gem size and the depth of it. Because this is a parametric object, you can actually change the depth of this. At the moment it's 2 millimeters by 0.8, so that's 2 millimeters deep and 0.8 there. You could change it to these different settings here. So I could have it as 3 millimeters by 0.8, and that gives me a better depth there. But the exact depth you want will, as I say, depend upon the depth of your gem and how you want it to fit. Alright, but I'll leave it at that setting for now. So the only thing that we need to do now is to add a connector, which I showed you earlier. So I'm going to append one of these connectors here. So if I go to File and Append, we always go through the menu system in Fluid Design until we get to Groups folder. Go to Connectors, and I'll use a 2.5mm wire connector and just append that from the library. And then I'll just make sure I select it over here, and I just need to pull it up and position it. So if I just switch to wireframe mode, I'll just perhaps move it down a fraction, and we need to look at it from the other angles now. So if I look at it from the left, and I just need to position it perhaps there. Okay, so that's in the right sort of location there. So that should be okay now. If you wanted, you could rotate this. Let's see, rotate it 90 degrees about the y-axis, so you could have it at an angle like that if you want your chain to go right through it, or if you want to use an additional connector and fit your chain, you could do that. Okay, so there is our pendant with our oval gem, and built from an Enneper curve. Now, what we now need to do is to convert this to a mesh and join the objects together. That's the connector, the Enneper pendant, and this ring. We don't want to join the gem, we don't want that printed, so we can just do X on the keyboard and delete that. So if we change this to a mesh, change the pendant to a mesh, and change the connector to a mesh, and then if we hold down the Shift key and go Tools, Object, Tools, and join those two objects together, and hold down the Shift key and select the pendant Enneper curve and join them together, we've now joined those three objects together, and we've basically got our 3D printable object. But we should always export this and run it through Netfab Basic. Now I like to export it as a wavefront object, so I'll export it to the desktop. It's actually a 20mm oval Enneper pendant, so I'll just export that to the desktop. Now that that's saved, what you need to do is to just go to Netfab Basic and go to Project and Open. Just go to the desktop, and it's a 20mm oval Enneper pendant that I've just created, and you just need to load that into Netfab and just run through the repair procedure in Netfab, which should only take us about a minute. And because they were all parametric smart objects that we were using there in Fluid Designer for 3D printing, although we've got a warning triangle here, if we just run through the repair procedure, I'm pretty confident. Yeah, we've got a few holes and a few border edge problems, but they're nothing serious to worry about. So we just run automatic repair, and if we click update, you see that they're all repaired. So we apply the repair and remove the old part, and then just save that. So you export it as a wavefront object, 20mm oval Enneper pendant, and just say yes. And that can then be uploaded to Shapeways to be printed, or on your own system. Okay, so the object that was created here, this was actually a 15mm oval gem. This is the Trillion one, and here are some round gems, and all of these are in fact created with the same sort of Enneper curve as I've demonstrated there, but with different P and Q values. So good luck in creating your own.